Welcome to the Explainer. Today, we are cracking open the mind of a machine. Seriously, we're going to look at some amazing research that's teaching AI not just to give us the right answer, but to actually show its work, to tell us how it got there.
So get this. What if an AI could do more than just flash a warning light? What if it could tell you, hey, this specific part is about to fail, and here's exactly why I think so? Well, that's what we're diving into today. This is research that's taking AI from just a prediction tool to a totally transparent partner, especially in the high-stakes world of industrial machinery.
Okay, so before we get to the cool AI stuff, we gotta understand the problem it's trying to solve. Think about almost any big industrial machine. At its core, something is probably spinning, right? And the things that let them spin, these rolling bearings, they are absolutely critical. But they're also one of the parts that fail the most.
And when one of these bearings breaks, it is a huge deal. I'm talking unexpected downtime, which can shut down an entire production line. That means massive economic losses, and even worse, it can create some really serious safety issues. And the tricky part, trying to figure out what's wrong just by listening to the machine's vibrations, well, it's like trying to hear a tiny whisper during a hurricane. It's just noise. So, naturally, engineers thought, hey, let's use AI for this. They came up with this technique called intelligent fault diagnosis. The idea is brilliant. Train an AI to listen to all those chaotic vibrations and predict a failure before it happens. It's a fantastic concept, but there's a catch.
And here's the problem. The AI might be spot on, right? It could tell you with, say, 99% accuracy that a machine's about to fail. But when the expert on the floor asks, okay, why? The AI has no answer. It's just silent. And that's the whole black box problem. This lack of an explanation makes it really, really hard for people to trust the AI's judgment, especially when safety and a lot of money are on the line.
Here's a good way to think about it. A traditional computer program, that's like a recipe. A programmer writes out every single step, and you can follow it from start to finish. You know exactly why you get the cake you get. But a black box AI, that's more like a world-class chef who makes the most incredible dish you've ever tasted, but just will not share the recipe. You get the amazing result, but how they did it, total mystery.
And this is exactly where a field called Explainable AI, or XAI for short, comes into play. The whole point of XAI is to get that master chef to spill the beans. It's all about cracking open that black box so we can finally understand the AI's logic.
Yeah, to put it simply, XAI is all about making these AI models interpretable. It gives us the tools we need to see exactly how an AI gets from point A, the vibration data, to point B, the diagnosis that says this machine is about to fail.
Now, in the study we're looking at, the scientists used a really powerful XAI tool called SHAP. You can think of SHAP as a kind of professional interpreter for the AI. It looks at a decision the AI made and then tells you, okay, this piece of information was super important, this other one was kind of important, and these over here, the AI barely even looked at them. It quantifies the influence of every single feature.
All right, so theory is great, but how does this actually work in the real world? Well, researchers at the Politecnico di Torino in Italy decided to find out. And they didn't mess around with computer simulations. Nope, they used real, heavy-duty, industrial-sized bearings on a proper test rig to see what this explainable AI could really do.
Their process was super straightforward. Step 1, collect a ton of vibration data. They looked at bearings in 3 different conditions: perfectly healthy, one with damage on the inner part, and one with damage on the outer part. Step 2, from all that raw vibration signal, they pulled out 23 different statistical features. Step 3, they trained a couple of standard AI models to tell the difference. And then, the final step, they let SHAP loose on the models to explain what on earth they were actually thinking.
And this is where things get really, really cool. I mean, sure, the AI models were fantastic at spotting the faults, but that wasn't the big story. The real breakthrough was what SHAP showed them about how the AI was making its decisions.
First off, let's just give the AI its due. Both models were right more than 98.5% of the time. I mean, that's incredible. Truly world-class accuracy. But, as we've been saying, being right isn't the whole story, is it? We need to know why.
And this slide, this is the golden ticket right here. This is what SHAP found. Remember those 23 different data features the AI had to choose from? Well, it turns out only a few of them were doing all the heavy lifting. Things like skewness, which is just a fancy way of saying how lopsided or asymmetrical the vibration signal is, and another one called shape factor. These were the absolute game changers. They were the clues the AI cared about most.
And the researchers said it perfectly in their paper. These specific features have the biggest impact on what the models decided. The AI wasn't just throwing everything at the wall to see what sticks. No, it had learned to zoom in on the signals that actually mattered.
So this leads to the million-dollar question, right? What happens if you take what you've learned from SHAP and you retrain the AI from scratch, but this time you only give it that handful of features that SHAP said were super important?
Well, look at this. The result is just perfect. It shows the true power of explainable AI. The new, much simpler model, using just 5 features instead of all 23, was just as accurate. And get this, in one case, it was actually a tiny bit better. It proves that when you understand how the AI is thinking, you can build smarter, leaner, and more efficient models.
And that, right there, is the big payoff. It's not just about accuracy anymore. When we understand the why, we can build AI that isn't just a powerful black box. We can make it more efficient, more robust, and most importantly, something the human experts can actually trust.
This is a really fundamental shift. We're moving away from just prediction and towards real, verifiable understanding. And that opens up a whole new world for how we use AI. It stops being this mysterious oracle and starts being a transparent, collaborative partner, especially in critical systems where you simply can't afford to be wrong. So it really leaves you wondering, doesn't it? Now that we can finally open the black box, what should we ask our AIs next?